for being present for this special webinar. Our thanks to colorHQ for organizing this and bringing you all together. My name is Jim Luttrell. I'm the Field Marketing Manager for X-Rite Pantone in the Americas. And with me today is Bruce Wright, who is our Application Specialist, who is sitting in Michigan. Bruce, welcome to the webinar.
Thank you, Jim.
Before we begin, let's just go over a few quick housekeeping points. We have a nice attendance today, but all of you are in mute mode. That will help the transmission of the program. However, as we're going through today's webinar, if you have any questions, just use the drop-down on your panel and type in any questions that you have, and then at the end we'll do a Q&A session together with Bruce and discuss any of those questions that you have. So let's begin our webinar. Our webinar series is part 2 today in this series with colorHQ. And Bruce is going to talk to us today about building a media profile. So Bruce, we look forward to hearing from you.
Thanks very much, Jim, and thanks very much to everyone who's in attendance today. We really do appreciate your time. Just to give you a quick overview before we get into the PowerPoint, which isn't terribly long. We'll spend more time in programs than we do in PowerPoint. What we're going to be talking about today is how to build a media profile, which is shall we say, a fancy way of saying, how do you make sure that you're getting correct color on your particular combination of paper and printer that you're using. So media profile, that's sort of the fancy term for what we're going to be doing today. And we're going to talk about the issues and the tricks that you might need to be aware of when it comes time to building a profile for your particular media with your particular printer. As it says here, my name is Bruce Wright. I'm with X-Rite and the Technical Support Department, and X-Rite and Pantone are one and the same company now. So we get involved with questions not just on X-Rite measurement products and software, but also on Pantone colors and how to use those colors effectively in a graphic workflow. The title of this presentation is Stop Guessing, Start Knowing. You can hit the right color if you have enough time, enough material, and enough money to throw at anything just by doing iterations of everything. But we think there's a better way, and that usually involves measurement devices and building an effective profile. So what we're going to talk about today is we're going to talk about media calibration, how to perform a printer calibration and establish correct ink limits. We're going to talk about X-Rite's i1 Profiler suite of programs, which includes Pantone Color Manager as well, to build a profile and the different uses that are possible in this software. We're going to talk about gray component replacement, why it's important, how do you use it. GCR, by the way, is gray component replacement. And how can I compensate for unique lighting requirements for my clients? Not everyone is going to be viewing your work in a light booth that's set to 5,000 Kelvin. Not everyone's going to be viewing your work outside in sunlight. So these are lighting considerations that you need to be aware of when you're building a profile as well. We're going to talk about the concept of pre-flighting my file, and that's where you would use the profile you build in something called soft proofing, and we'll touch on that in Photoshop. There are other programs that do soft proofing, but Photoshop's perhaps the most prevalent and powerful. We're going to talk about Pantone Color Manager and how we can see whether we can effectively get a particular color in your print. Now the first step, if you're printing through a large format inkjet printer or through a high-speed color laser, your files will go through what's called a RIP, or a raster image processor. Now, one of the things that's very important is that you don't exceed the amount of ink or toner that a particular material can handle. If we're talking about inkjet printers, then a plain bond paper would probably be your least capable of holding much ink before it saturates and turns into an unsightly mess. If we're talking toner-based devices, then 20-pound copier bond would be your worst offender in terms of how much color toner it can hold before it starts to blow off the face of the sheet. What you're looking at here is a calibration chart, or sometimes called a linearization chart, where you print a ramp of 0 through 100% of each of the colorants that are used, cyan, magenta, yellow, black in this case. What we're trying to make sure is that when we're asking the RIP for 50% black or 30% magenta, that we're actually getting that percentage. And what you'll find is that printers need to be linearized, so we bring them back to a known state. You want to make sure that at a minimum, the printer is able to give you a reliable amount of each colorant throughout the 0 to 100 range. So you'll print out this type of calibration or linearization chart for almost every RIP with almost every printer that's out there. This is step one. You need to make sure that the print engine is at least in a known state before you do anything else. Then if you're working with an inkjet printer, then something that's very important is the concept of total ink limit. And total ink limit, in this case, you'll notice that there's a variety of patches here that are composed of various percentages, cyan, magenta, yellow, and black. And what you're looking for is you're looking for at what point is too much ink occurring. Now, you might be able to see clearly, I can here on my screen, hopefully you can over the wonder of the internet, that some of the patches have what look to be fingerprints in them. And those are deliberately there. They are in fact fingerprints. And what we're looking for here, excuse me, we're looking to see when the ink is not drying successfully on the sheet. That's the point where we've reached the point of saturation. Too much ink is going down. And in that case, A, you're going to have a problem with the print not drying successfully in time, or B, you're not going to get any additional image quality or color density by depositing more ink in this situation. So what you're trying to find by printing out this ink limit check chart is at what point you want to cut back and limit your ink percentages. What we see here is that definitely 340 is too much. I think probably for this particular material and this printer, something in the neighborhood of 310% total ink coverage between the cyan, magenta, yellow, and black would probably be the maximum you would want to go to. So at that point, you enter your ink limit. And the linearization file that you created with the chart that was beforehand and this ink limit chart, these are values that you then would enter into whatever RIP you use to control your printer. And what this means is we're just setting the thresholds for how much ink is enough. So once you've done that, then we're going to talk about the concept of lighting characteristics and how they affect your resulting color. Now what you're seeing here is that in this case, this is vinyl. It's being applied to a car. If you're looking for a neutral gray and you print out this file, the way the color is built looks neutral, or shall we say, doesn't have a defined color cast to it when you view it in daylight, which is 5,000 Kelvin, or D50 is another way to describe it. However, if that same graphic is viewed under fluorescent lighting, then you see that what used to be a neutral gray is now turned into a bluish-green gray. And that's because the color of light has a big impact on the final result that you see. Now, if you knew that your work was going to be viewed in a particular lighting condition, that can be built into the profile. And we'll show you where that step is in i1 Profiler. So just suffice it to say that if you knew that your work was going to be viewed in a particular lighting situation, for example, like the beverage aisle of a Sam's Club or Target, where you could find out what the lighting color temperature was in that area, you could custom tailor your profile to look neutral under that lighting condition. If something like a car is going to be viewed under all sorts of different situations, then you might have a situation where you can't build a profile that's going to be neutral in all cases. But what you can do is you can increase what's called gray component replacement. And gray component replacement is when we take a color that's made up of cyan, magenta, yellow, and black, and take away equal amounts of each one of those three colors, cyan, magenta, yellow, and replace it with the same percentage of black, because those three colors should themselves produce a neutral gray. When we add more gray component replacement, which is to say we cut down the cyan, magenta, yellow, and black by a certain amount, and then add in a bit more black into the color mix, then we see that even under a different lighting condition, daylight to fluorescent, things have become more stable. And what we've done here is we've tried to take and build the color in a different fashion, because with cyan, magenta, yellow, and black, you have a variety of different ways to build a color. We're trying to build it in a way that will be more neutral under a variety of lighting conditions. So gray component replacement has the effect of giving you a more neutral result under a variety of different lighting conditions. Now, we talked about the concept of soft proofing, and this is something that for anyone who's in the business of print for pay is a very, very valuable thing, because soft proofing allows you to make your mistakes without spending any money. And what do I mean by that? What I mean is that after you've built a monitor profile, which everyone should be doing at a minimum, Then you can build a printer profile, and then you can open up Photoshop, go to the View menu, Proof Setup Custom, and then select the profile that you've created. So after you've done that, then you can see on screen what the likely result of your print is going to be. That can save you from some very expensive reprint situations. So once you've built a profile, before you actually use it, what you want to do is take it into Photoshop or Lightroom, if you happen to use Lightroom, and do a soft proof with that profile. And again, the way to do that is go to the View menu, Proof Setup, Custom, and then you'll have a drop-down menu with all the various profiles that you might have loaded into your computer, and then you can select the profile that you have, and then there's a checkbox for preview. You can toggle that off and on. So that's something that we certainly recommend everyone do once they've built profiles before they actually use them. Soft proof with them in your choice of whatever program you use that has soft proofing. Photoshop and Lightroom being probably the two biggest examples of that being used. So here's what you'd see in the drop-down menu. The proof setup is custom, and the device to simulate in this case is the profile that was created in this case for a printer that was using eco-solvent inks on a semi-gloss paper, and the resolution was printed 720 by 720. When you build a profile, it's important to understand that that profile is based on the printer type, the material or paper type that you're printing on, the ink set that you're using, and the resolution that you print at. Change any of those conditions and you should build a separate profile for that. So again, it's the combination of the printer, the paper, the ink set, and the resolution. In this case, black point compensation is something that you can engage or not engage in Photoshop. I would not recommend using the simulate paper color. We found that to be less than accurate in most cases. And here's the preview checkbox that I was referring to. You toggle that off and on and you'll see the result on the screen. Now, also in Photoshop, you have a tool called gamut warning, and gamut warning just alerts you to the areas that are outside of the gamut of the profile that you created. That's to say that if you feed it an image and it's got a color that's out of gamut, it's going to be moved into the available gamut that that printer can produce on that material. It doesn't mean that nothing's going to print there. It means that the color won't be as accurate as perhaps the areas that are within gamut. So in this case, the areas that you see here that are outlined in this neon green, these are the areas that are saturated to a degree that you can view on a screen, but you'll never get that same exact degree of saturation on a printer result with the particular material that we're printing on. So in this case, a little bit of judicious editing in Photoshop will bring those areas down to the point where they don't really matter from a subject standpoint. And you want to do your editing before you do any sort of conversion to different rendering intents like relative colorimetric or absolute colorimetric, if you will. Now there's a few tools that are involved here, and we'll briefly touch on the use of them. What you see here on the left-hand side is the i1 Display Pro, and the i1 Display Pro and the i1 Pro 2 devices can be used with i1 Profiler software. We'll look at that in a minute. There's Pantone Color Manager, which is our way to help you understand electronically what the various Pantone libraries can do for you. And we also have training services that are available through X-Rite itself. But let me do this. I'll escape out of PowerPoint because you've been patient with that. And let's go directly to i1 Profiler. In i1 Profiler, when I have an i1 Display Pro, this device attached, you'll see that I have the ability to do display profiling, projector profiling. Printer profiling shows up as demonstration only, and scanner profiling. i1 Profiler software has two modes. It has a basic mode and an advanced mode. This isn't to say good quality and better quality. It's to say excellent quality in either case. This is more simplified workflow. This allows a more customized workflow. So let's just have a quick look at printer profiling, and I'm going to unplug my i1 Display Pro for a second. You'll see that everything goes to demo, and I'll plug in my i1 Pro 2 spectrophotometer, which is the device that you use for measuring the color patches to build a printer profile. And after I connect that device, then the computer should recognize it. The lights on the i1 Pro 2 light up, and now I'm seeing that I have all my licenses available. So in today's session, we're going to talk about printer profiling. Let's go have a look at the basic mode of printer profiling. Now remember, we've done this situation already where someone has already done their linearization and their ink limiting. Then what will happen is you'll go and select the printer that you want to print to. Now in my case here, the printers that I have are both RGB printers. This Canon MP500 is a desktop printer that I have. And then our department has this Stylus Pro 2400. that's attached to a particular computer that we have. And then what you can do is you can choose the targets that you want to use. Now in the basic mode, we've already built the targets for you. We've got small, 400 patches, medium, 800 patches, and a large number of patches, 1,600 patches. Now people always ask us, well, how many patches should I use? I'd have to say that anything over 1,000 patches is probably overkill for a small desktop printer. If you're working with a larger grand format or a large format printer, then something between 1,000 and 1,500 patches is probably sufficient. It's not the number of the patches that's important so much as it is the composition and the color characteristics of those patches. So what you can do after you've decided the patches that you want to measure, then you can either print them directly from i1 Profiler, or you can save them out as either a TIFF file, an EPS file, or a PDF file, and then drop those files into whatever method you would print your files. The important thing is when you go to print this target, you need to make sure that color management is turned off in either your printer driver, if you're printing directly from i1 Profiler, or in your RIP if you're sending these files as a TIFF or an EPS or a PDF through your RIP. So that's the procedure. After you've printed these targets, then you would measure them with the i1 Pro. And what we're going to do here is we're going to switch over and show you the advanced mode because that's something that we can go and simulate with files that we've already done. I'm not going to force you to sit while I read through a full patch set. So let's go again to talk about printers. Now in printers we have a choice. We can profile an RGB printer, which would be a desktop inkjet printer, or a large format printer that's being driven through the printer driver from either HP, Epson, Canon. Those are probably the three most popular ones for printer driver type printers. Then there's also CMYK printers, and that would be any of those inkjet printers that's being driven through a RIP in most cases. Almost all RIPs are CMYK, although there are some RGB RIPs that are out there. Color toner printers, color laser printers, those are CMYK printers. Then if you have inkjet printers with other colorants beyond CMYK or light versions of cyan or magenta, then you might have a CMYK +1, +2, 3, or 4 colorant printer. So i1 Profiler can allow you to profile up to an 8-color printer. So that would be someone who had a CMYK, red, green, blue, and perhaps orange. Those would be the 8 separate colorants. Let's talk simply today and go to CMYK printer. Linearization, for someone who didn't have a RIP, they could do their linearization in i1 Profiler, but most people are going to be doing their linearization, their ink limiting in their RIP. We put it in this feature, in the program rather, so someone who doesn't have that feature at a RIP will be able to do this. Profiling really is where you're going to do your work. And in profiling, there's a workflow down along the bottom here, and there's assets along this side. Assets are a way to try and simplify the workflow. So we can take a patch set, something set up for a CMYK printer. I've got a 2002 patch set, and I'm going to drop that in here. And I can see that it loads 1,485 patches. If I want that to be formatted for a particular device, in my case an i1 Pro, then I'll take the i1 Pro, where are we here? i1 Pro I/O. This would be if I had an I/O measurement table, and I'll drag and drop that test chart configuration in here. And what that does is that arranges those so that they'll be properly seen by that measurement i1 Pro 2 in the I/O table. And then we can look in the test chart and we can see the format that we have here, and we see that our device setup is for an i1 Pro 2. And we can choose a different paper size if we wish, or we can use the default layouts. After you've done that, then you can move on to the measurement. And let's just take a default measurement that we've done in the past, and we'll drag and drop that in here. And what you'll notice is that the measurement will populate both the measurement information as well as the test chart and the patch set backwards. So this measurement information contains all of that information. Once you've done the measurements, then if you had a customized lighting condition, this would be where you'd specify that. Now D50 is the standard lighting condition that's described for most graphic applications, but you might choose to use a different lighting temperature if you knew what that was, or if you wanted to have a custom, you can measure that with your i1 Pro 2 device. And once I calibrate my i1 Pro 2, then it would allow me to do a measurement of an ambient light situation. So if I wanted to make sure that my work looked neutral and correct under a particular lighting condition, I could take out a laptop computer along with my i1 Pro 2 and measure the ambient color temperature in that area to build a proper profile for that lighting condition. So suffice it to say, we're not going to do that today, but that is something that you can do. We'll cancel out of this. After you've done your lighting, then you go to Profile Settings. And in Profile Settings, what we have here is a very nice feature that allows you to, again, see what's going to happen before you go and build the profile and before you spend any ink doing anything. So what you can see here is that we can change our total ink coverage, and although it might be difficult to see, I'll get fairly extreme, you should notice that the on-screen rendition might get a little bit lighter. If it doesn't, then I apologize. It's just due to the limitations of web-based presentations. But I can assure you that my image on my screen is getting darker or lighter based on that. We can also have a look at the various curves, and if I turn off the intelligent black, I can then go and have a look at the various curves that we have here. And we can see if we affect our black start point and what our maximum black amount is going to be. I'm going to increase my maximum black and change my start point. So by changing the curves here, we can get a different result. And more importantly, once we do those edits, we can see dynamically here with the sample image what the result is going to be when I make these changes. Again, I apologize if they're not being dynamic for you across the web. And you can see them on a plate-by-plate basis. So if you want to see what your impact is going to be on a particular plate when you make an adjustment to just the black channel, you can see here dynamically what's going to happen. After you've made your judgments on what's going to happen on a plate-by-plate basis, then you'll typically come back to the composite view again. There are other images that are loaded in here if you want to see an image that has a particular color characteristic to it. But this allows you to get a very good idea of what's going to happen to your profile if you make the adjustments that you make. Then you would go ahead and say, let's create that profile. And in this case, I will create this profile and just call this webinar test. And I'm going to create and save a profile. You'll get a progress bar down here. The more patches you use, the more computation it has to do. This is a very small patch size, so it's going to chew through this pretty quickly. The majority of people who are building profiles will probably spend a minute to 3 minutes in the computation stage, depending on how quick their computer is. This is a laptop MacBook Pro, not the fastest machine, but certainly not the slowest in the world either. So it's going to go through right now, and we're up just getting close to the 60% mark. And after it cranks through that profile, then we'll get the result. And my device, although you can't see it here, my device is pulsing to let me know that the software is working, seeing the device, and it will complete in just a second. And what this gives us is it gives us the ability to see the gamut of this profile. And if you had a mouse on your computer, you could wheel in and out to zoom in or out on this. On my particular laptop, I'm just looking at it this size. But what you're looking for in a profile is you're looking for it to have a smooth side to it. It'll be a geometric shape. Sometimes it'll be larger, sometimes it'll be smaller, depending on the characteristics of the material that you're printing on. But what you're looking for is that it doesn't look like an asteroid. It doesn't have rough sides to it. So we've just built ourselves an ICC profile. And that ICC profile should be described down here in my ICC profile. So these profiles have already been saved in the past. Now, if I wanted to look at an earlier profile that I built, all I have to do is drag that profile into the ICC profile area. It will go through and populate all that information, and then I can go and have a look at my profile settings to see what those were set to. So if I knew I had a good result, I can go back and revisit those when I build my next profile. So I1 Profiler is the engine that's used for building a profile. Now sometimes you're going to have people that are going to come in with a particular color that they want you to match or duplicate in their prints. And what we'll do here is we'll go back to the home, and under the measure chart area, you have the ability to set up with your i1 Pro 2, and I'm going to set my patch layout to a row of 1, a column of 1. And what this means is I now can measure a single patch. So what I'm going to do, as I've already calibrated my device, I'm going to do a measurement of a Pantone color that I have, and I'm going to put the spot measurement tool on it. And let's go. Measurement, and let's measure. I just want to do a spot measurement, my mistake. And what I have done now is I've got that spot measurement, and now I can go and save that file. If I want to save that file, I can give it a color name, save it as a CXF file, and then I can incorporate this color into a profile. So if someone wanted to bring me colors that they wanted to be sure to duplicate, I can save those colors, and I can make sure that those colors get incorporated into the profile patches that I'm printing, so I can print those and reproduce them more accurately. So you can measure spot colors in I1 Profiler. There's also, let's cancel out of this, there's also an aspect to doing this within Pantone Color Manager. And Pantone Color Manager is for someone who comes in and says, I want you to reproduce a particular Pantone color in my work. Now this can be challenging because most people come armed with a Pantone formula guide, which is designed for someone who's mixing up custom spot inks. Now that's not what you're working with if you're working with a printer that uses cyan, magenta, yellow, and black inks. So what we'll do here is we'll show somebody what happens when you apply a particular profile. And I've got a variety of them, so I apologize. So we're going to take and show what happens when you apply a profile that we created for a wrap material printed on a roll-in printer. And now what happens is that my colors are going to change, and in some cases those colors are going to change dramatically enough that you would not like to see the result. And what we're seeing here is that some colors will mutate where someone wouldn't want to see them anymore. Let's go and take an extreme example with US web-coded swap. And what you see here is in these saturated colors, I have a color on the left-hand side, which is the spot color, the color on the right, which is the color that's likely to result with the profile that you're building. So if someone is particularly interested in identity colors, as a company that has a logo color would be, after you've built your profile, then you would want to open up Pantone Color Manager and then see what happens when you apply the particular profile. You'll notice that in many cases, when the profile is done on a better material for a better substrate, then the area that it will suffer will be less. So again, let's switch between US web-coded swap and Grackle. Grackle is kinder to some colors than others because it has a wider color gamut available to it. But when you build your profiles, this is a good way to verify what those profiles are going to have in terms of an impact on a Pantone color. One other thing, oops, don't do that. Let's go back to Pantone Color Manager. One other thing to keep in mind is that you want to be starting with the correct guide. Now in this case, when I go to a particular fan deck, and we'll go to fan deck, the solid coated one is a popular one because ink vendors used to give that out for free. But you probably want to be working with what's called the Color Bridge coated. And the Color Bridge document shows you a color when it's been converted to CMYK. So this is something that gives you the ability to see on a Color Bridge document. It'll show you both the spot color as well as the CMYK approximation of it. And this is probably a much more realistic target for someone to look to. So if I start with my Color Bridge coated or uncoated, then I could apply a particular profile and then get probably a better idea of how well I'm going to be able to reproduce these colors. And as we scroll through this, most of the colors don't appear to have much of a degradation when they've been converted down to CMYK in this case. If you were to look at them compared to a spot color, yes, there'd be some slight changes. Now the nice thing about Pantone Color Manager, it's incorporated into the I1 published suite of software, so someone who wanted to go ahead and incorporate those Pantone colors could save out a palette. And let's go and have a look at palettes for a second. So let's go to My Palettes. And you can have a palette that you've done from colors, or you can extract a palette from a certain from a certain image. In this case, from Kermit the Frog. So if someone brought you in an image that they wanted to say, I want to make sure that these colors are reproduced accurately, I would save the palette of colors from Pantone Color Manager, and then I would incorporate these colors into the colors that I use in my target in I1 Profiler to build the profile. So these two programs are designed to work together. You can do measurements and get a lab value of a spot color if you use I1 Profiler's measured chart. If someone wants to make sure their Pantone colors are reproduced properly, you can do that by taking a palette of colors and then importing those into your profile that you're building. So that's a very quick, and I apologize for the brevity of it, it's a very quick overview of what you can do in both I1 Profiler and in Pens on Color Manager.